Okay, now I will be doing question 9. So the important concept in question 9 is conservation of momentum. Okay, so momentum is, I'm going to write the equation for it. So it's P is equal to the mass times the velocity. So momentum is conserved if there is no external force acting on the system. And for problem 9, there is no external force acting, so we can use the principle of conservation of momentum in this case. So basically, this is momentum, P equals mass times velocity, and conservation of momentum is that the initial momentum is equal to the final momentum. So that's the principle that we are using here in this problem to solve it. Okay, now I will read the problem. At time equals t1, particle A is observed to be traveling with speed 2v0 divided by 3 to the left. The speed and direction of motion of particle B is. Okay, so first I'm going to draw a picture of what's happening in this problem. So this is particle B, and it is not moving, and it is located at x equals 0. And then this is particle A, and it is moving at a velocity towards particle B, and it is at a distance 2d away from it. So in this case, in terms of this problem, I'm going to define the left as positive because that's where it's moving and it's positive. So I'm just defining what my axes are, or in that case, I'm just going to say left is equal to positive. So for my final answer, since in these answers it shows to the left or the right, so if my final answer is positive, then it's moving to the left. So I know that for the answer. Okay, so now I'm going to solve the problem using the principles of momentum. So first I'm going to show the initial momentum of the system, and the initial momentum is the momentum of particle A plus the initial momentum of particle B. So initial particle A, initial particle B. So what that's going to be, particle A, it's the initial momentum is mv naught, and then for particle B, since it has no velocity because it's at rest, its initial momentum is going to be 0. So the initial momentum for the whole system is mv naught. Okay, now for the final momentum of the system, so that is going to be m. So this is for particle A, and then they say in the problem that it's moving with a speed of 2v0 divided by 3, and then plus the final momentum of particle B, which is just m times v in this case. So now I have the initial momentum and the final momentum, and then I can set them equal to each other because of conservation of momentum. So I'm going to do m v naught is equal to m 2v naught by 3 plus mv, and then I can cross out all of the m's in this case because they're in all of them, so I can just cross them all out. So I'm going to do that. So then I have v naught is equal to 2v naught divided by 3 plus v. Sorry, I forgot to define this. This is the velocity. This is for particle B. And remember, in this problem, we're trying to solve for the velocity of B at the end. So then I'm going to subtract this from here. And I can get v naught minus 2v naught over 3 is equal to the velocity of B. Then I need to solve this, so I'm going to just an arrow to show it. 3, just so I can subtract it correctly. And then this gives me v naught over 3 is equal to the final velocity of particle B. So that is my answer. And since v naught over 3 is positive, it will be moving to the left. And so that means the correct answer to this question is B, which is v naught divided by 3 to the left. So that's the answer.